Okay, this video is going to be pretty short. I'm mostly recording this because I don't trust that my handwriting was neat enough on these slides. Some students asked to see if they could get a copy of everything, especially period 6, because we didn't go through the whole packet in class and people wanted to have access to that, which of course I want to provide for you guys. So I am going to make this pretty fast, mostly just reading my handwriting, maybe explaining a few things as we go. At any point in this video, if you need to pause it to look at something longer or compare it with something you've done, then of course pause the video. So the first slide was just the design process. You do want to be familiar with those steps and what kinds of things are in each step. The decision matrix, this says helps evaluate ideas based on various criteria. And so you might have your ideas, you would probably name them, and then you'd rank them on different aspects of it. And then you'd either be looking for the highest number or the lowest number, depending on how you set it up. Design brief would be in step 1. A fusion model would be in step 4. An invention is something new. An innovation is an improvement or repurposing of something that already exists. This is an isometric sketch. This is an orthographic multi-view. And it said we did this in, I think we did this in both classes, just not quite as much time. We did review it in class with that matching. If you were absent, what I want you to do is try to match them up. Maybe don't look too closely at this, and then check just a few of them. So maybe try to do like the top row or something, but stay like the top row, like 1 through 4, but stay away from 2. So just do like 1, 3, and 4, see if you can find what those match up with the letters, and then check them to get a little bit of review. Longest view, longest side is how you determine the front view. That says longest, which is often, it's not 100%, but usually the longest. And what's really important is the most distinct shape. So that says most distinct shape. The 3 most common views in an orthographic projection are the top, front, top, and right. And they are put on the page like so. The type of sketch used to communicate info to a manufacturer is the multi-view, and the type of sketch used in brainstorming is a concept sketch. It's like really, really fast. You want to get your idea out there. Okay, this one, when we did this in class, we actually reversed the order. So an object line, this says it's solid and it represents the edges of the object, specifically the edges that are visible from that particular view. And then looking at this sketch, here is an example of an object line right there. A hidden line is dashed, and it shows details not visible from that view. So from that view, it's probably going to look solid, or it might look like something else, but there's something happening behind it. This right here, answer choice E, this is an example of a hidden line. A construction line is very lightly drawn, and it's used to guide your sketch, but it's not actually part of the sketch itself. That would be this. I don't actually know what this arrow is pointing to because I don't see anything. Maybe they meant like this line here. I don't know. But those are the 3 lines there. And then on this, we had the object, the construction, the center line, which is also dashed, usually with like longer dashes, and it would be in the middle of something. And then these are section lines that show that you've sliced away a part of the object, and it's to say like, okay, I sliced this away and this is solid. It's kind of an awkward sketch that they have there. I think they were just trying to get as many lines as possible onto it. On this flow chart, just never dimension to a hidden line. If I were going to put something on there with a dimensioning error or something, that would be one of them. And then the over and under dimensioning, again, probably one of the most difficult things that we do in IED. This, when we talked about it in class, this is a really simple object up here. So a really simple object, there's no way that you need that many numbers. in order to get it dimensioned. So this says way too many dimensions, need to eliminate the duplicates, and there's tons of duplicates in there. This little notation here is move those measurements to the inside if possible. A lot of those you can actually delete because they're duplicates, so they don't even need to be there at all. When possible, you want to dimension stuff in this interior space, but sometimes you'll have details and stuff that there's no better place to put it than in the margins. So that's one of those try to do it, but it's not a hard and fast rule. These are our hole notes, the different kinds of holes. And then in class, I gave you this. So this is not in your packet, but I do expect you to have it when you turn it in. So this is actually an example of a hole note, and the directions were use the hole note to the left to draw the profile sketch of the hole and label where each dimension in the hole note goes. And so the little 4 times just means there's 4 of them in this, and then you've got 2 different diameters with their tolerances. Don't worry about labeling tolerances. And then you have a depth with the depth tolerance. So your sketch should look something like that. And of course, this means that it is a counter bore hole. So it tells you a little bit about the shape of the hole. Reading the calipers, I think this was pretty straightforward. So this is 5.621, and then I said it was 0. I said it was right on there. 3.6660 or 3.6659. Feel better. Yeah, so you should be able to read that, make sure you know where those numbers are. Now, I did caution in class, if your needle is up in this spot up here, there's going to be an extra 0 in there that's really easy for you to miss. So for example, if the needle were over here, it would be 3.60, and then like if it were up here, it's 0.6. So that 0 right there. So just be careful if the needle is up there. It's just easy to miss, like that there is a digit of 0 in there. This is accuracy and precision. So this is okay, up here it says often done with bullseye. Okay, that's usually how this is illustrated. This one is neither accurate nor precise. This one is precise but not accurate. This one is accurate but not precise, and this one is both accurate and precise. So that's what all those notations there. Here, what this said is it should still be precise but not accurate, i.e. that means that is it'll be off by the same amount each time. So it's like this situation here where if you're off by a certain amount, you're still going to be pretty precise, clustered, but you're going to be off by that same amount each time. We skipped this in class, and I'm going to skip it in this review just to make sure everybody's got the same amount of work. Like everybody's accountable for having the same stuff in their packet. Hopefully it's not an issue if you're given your conversion factors, which you will be. I'll let you guys read that. We went over that in class. Do make sure that you know what all these definitions are. Now we have the mean, median, mode. We did do this in class. So the mean was 12.2, coming from 134 over 11, which is like my scratch work there. Median is 7, mode is 3, range is 57. And then there is a box and whisker plot on your EOC. So we did go over that in class. We counted by 5s because of that stupid 57 is just way out there. To do your box and whisker plot, you need your minimum, your first and third quartile, your median, which is the second quartile, and your maximum. Your quartiles are the medians of the bottom and top half. Make sure that you do follow the rules for finding median, and that if you have a middle number as your original median, you throw that out. If you split the numbers down the middle initially, you don't throw anything out. And then this would go minimum, quartile 1, median is where the line is, quartile 3, and then the maximum is over there behind my head. You were asked to copy this, so hopefully you've got it. You need to know those percentages, particularly the 68, the 95, and the 99.7 with that standard standard deviation there. Pause the video here. This says 68. This says 34 and 34. This says 95. This says 13.5 and 13.5. This says 99.7. This says 2.35 and 2.35. All of these are percents. This is 0.15. That definitely got messy. It's a little bit clearer over here on the right, 0.15%. And these are plus and minus 1, 2, and 3. And then that is the lowercase sigma for your standard deviation. So pause the video if you need to and make sure you get that copied down. The weights of adorable fluffy kittens. So the mean was 3.6. The standard deviation was 0.4. So we add 0.4 and subtract 0.4 to go on either side. 2.8 and 4.4 are within the two standard deviations, and that is our 95% interval. So that says 95%. Hopefully you call all those numbers. Again, pause if you need to. Our tolerances, make sure you do review the specific types of tolerances and the specific types of fit. The unilateral, this first one is unilateral, and sometimes underneath here you'll see like minus 0.00 to emphasize that it goes in one direction. This is bilateral, and this is limit, where they actually give you the upper and lower limits. If you are asked to find the tolerance, you are not to give like the plus and the minus. You're actually supposed to subtract the higher number and the smaller number. So I did the 2.52 minus 2.48, and it says 0.04 underneath here. The 4 got a little cut off. So that's the tolerance. You can get them by looking at the space between here. So this would be 0.06, or you could actually add and subtract that and get the tolerance that way. It's a little bit more work. So again, pause if you need to. This is asking the upper limit. So you're given the measurement, you're given the tolerance there. So to get the upper limit, we would be adding. And so this ends up being 3.765. There are no units on that. So I guess we don't put any units on it. The analysis, I know I emphasized, at least in class today, I would need to review these because I won't keep them straight. Not my area of expertise. So I would need to make sure I knew which ones were elements and which ones were principles. The type that involves the disassembling of the object is structural. So that is what that says, structural. Again, I am scrolling with my finger on a computer screen. It's not the easiest way to write. So that says structural. These, I know it says for 3, and we talked about it each of class. Like I felt pretty good about like 2 for each of these. For this one, line and shape, and this one, texture and value. I think somebody brought like the value out, like the idea of like lighter and darker. For this one, I picked rhythm and proportion, and for this one, balance and contrast. These are a little bit more subjective, but honestly, like know which ones are which, because a good multiple choice question would be like, which one of these is not a design element, and like 3 of them are design elements and 1 of them is a design principle. So you would need to know which one didn't fit in that category. For the volume, volume of pretty much anything is the area of the base times the height. If it is pointy, it's 1/3 the area of the base times the height. It's just like one formula for everything. You are going to be given all your formulas. So for this, the base is a circle. So you want the area of the circle, which is pi r squared. I plugged that in there. So we end up with 16 pi. And then it's the area of the base times the height. So we take the area of the circle and multiply it by 10 to get 160 pi cubic centimeters. If needed, you would use like 3.14 for pi and get another number for that. On this one, the base is the 5/4, so the area of the base is 20, and then you do the area of the base times the height, which is 2, which gives you 40. Most people know that formula as length times width times height for the volume, but area of the base times the height also works for that. Again, pause if you need to on any of these slides if you need to write something in or supplement your notes. This is density. The formula for density is mass over volume on your reference sheet. It's weird. It's like mass equals density times volume. It's just like rearranged a little bit. This, you need the volume of the wood. The wood is apparently a block, so 3 times 4 times 6, commutativity, is 72 cubic centimeters. So we have 80 grams divided by 72 cubic centimeters for 1.11 grams per cubic centimeter. The units come out of the math there. This, we have some kind of thing that's irregularly shaped, so you can't use a formula. So they're doing the water displacement. To find the volume, you would have to take the larger volume minus the smallest volume. That'll give you the volume of what was added. So that is 16.2 milliliters. We know it's 43.6 grams. So density is mass over volume, 43.6 grams divided by 16.2 milliliters, which gives us 2.69. And this says grams per milliliter. It does ask for grams per cubic centimeter. Please remember that 1 milliliter is equal to 1 cubic centimeter. Milliliters is typically used for liquids, and cubic centimeters is typically used for solids, but they're actually the same amount of volume. All right, moving on. This graph is just really bad if you were in class today, which was an A day. I kind of complained about this graph a lot. When was Ms. Ewan at home? Here, here, and here, wherever they are. I don't like it because we don't have any numbers to really accurately place this. Somebody said 7. Sure. I mean, close enough. And then over here at like 17 or 18, and then over here at like 22, but we're really kind of estimating that. When was Ms. Ewan moving the fastest? Whenever the line is steepest, but without definitive numbers, we're really just kind of trying to do this by eyeballing it, and they all kind of look the same to me, if I'm honest. So this looks about the same steepness as this, and the same steepness as this, just going in the other direction. So I can't tell. So I answered that when the line is steepest. Remember that the slope is equal to the velocity. Okay, slope is equal to the velocity. So and that includes your direction as well. So if the slope is negative, it means that Ms. Ewan is heading in the other direction. So positive slope is one direction, negative slope is the other direction. There are a lot of good questions you could ask about this graph. It's just not either of these. So a good question would be, how fast is Ms. Ewan moving at 10, at 10 hours? Well, 0. She's not moving. You could ask, like, what was the furthest Miss Ewan was away from her home? It would be 10 miles. You could ask, what was the total distance that she traveled, which I think was like 6 down, 6 back for 12, and then up 10 and back 10 for like 32. So there are some good questions that you could ask about that motion graph. I just don't think that either of those questions are it, for what it's worth. Okay, this we discovered there's an error in this, so I do want to spend a little bit longer on this particular one, because I started to do a thing where I was showing the class how you can use the units to figure this out, and then it turns out the units are actually wrong, and so it didn't work, which is like kind of self-conscious, like for me, like, wait, hold up, like this should have worked and it didn't. So the reason it did not work is because the units on those answers are wrong. Those answers should be pounds per foot is what those units should be. So if you don't remember the formula, you can actually use the units, assuming the units are right, to figure it out. So it should be pounds per foot. So as you look at the answer choices, even if you don't remember the formula, you know that the answer should be in pounds per foot. So you go take your pounds, put it on the top of the fraction, go take your feet. Now this was 6 inches, so we have to change it to half a foot. Put it in the bottom. 12 divided by half is 24 pounds per foot, which is answer choice D. So hopefully, like, that is not something that's going to happen on your EOC, because yeah, that's an error. So the unit should be pounds per foot, and you can, if you don't remember the formula, which was this, okay, you actually can get it like kind of working backwards with the units, which is something that's absolutely worth knowing, but only if your units are correct. So there's that. Last slide here is the Ohm's law. Ohm's law is on your reference sheet. It's V equals IR, which doesn't help you a whole lot if you don't know what those letters mean. So this has to do with circuits. It's voltage is equal to current times resistance. I think voltage for V, like, that's pretty good, and resistance R. The one that's kind of weird is current is I. And then the units for those, voltage is measured in volts. Current is measured in amps or amperes, and resistance is measured in ohms. The symbol for ohms is this. That's not drawn really well, but it looks like that. It looks like that. It's an omega would be the symbol for that. Practice problem: a circuit has 330 ohms of resistance and is connected to a 5-volt battery. What is the current through the circuit? I would love to teach you guys lots of currents and circuits and stuff. That is my field of expertise, more than design elements. But basically, you have your formula. 5 volts goes for the V. The ohms is your resistance. It goes over here. It's a one-step equation. Divide both sides by 330, and you get I is 0.015 amps. And so that would be a really simple Ohm's law problem. Also, don't forget what we just did with friction. So the force of friction is equal to mu times that normal force, if you end up seeing anything like that. So I hope this video helps take you through the review and helps you read anything that was too messy for you to see over the weekend. If you're watching this before you take your EOC, if you've got questions, I think you guys know how to reach out to me. So hopefully this helps, and let me know if you need anything.